Hello students, welcome to Meetu maths classes. Today's topic is from class 12, chapter 7 integrals, and we are going to take some important questions of NCERT miscellaneous exercise. So let us start with our first question, that is question number 36. Prove that integral minus 1 to 1 x raised to the power 17 cos raised to the power 4x dx is 0. Now to solve this integral, let our I is integral minus 1 to 1 x raised to the power 17 into cos raised to the power 4x dx. Now to solve this integral, जब भी आपका डेफिनेट इंटीग्रल का क्वेश्चन है between minus a to a, you are going to check whether your function is odd or even. So let your fx is x raised to the power 17 into cos raised to the power 4x. Now you are going to check f of minus x, that is minus x raised to the power 17 into cos raised to the power 4 of minus x. That will give you negatives because the power is odd. Minus of x raised to the power 17, cos of minus x is cos x, and raised to the power 4 है, वैसे भी आपका cos raised to the power 4x ही रहेगा, and this will give you, this is your fx only. So f of minus x is minus of fx. That implies your fx is an odd function. Now there is a property that in between minus a to a, if you have to integrate your fx, and so this can be written as 2 times integral 0 to a fx dx if fx is an even function, and this integral is equals to 0 if fx is an odd function. And here your I is between minus 1 to 1, your function is an odd function. So this integral is directly equals to 0. Now your next question is question number 37, that is prove that integral 0 to pi by 2 sin cube x dx is 2 by 3. Now to solve this integral, let I is 0 to integral 0 to pi by 2 sin cube x dx. Now here we can do one thing. We know the formula for sin 3x, that is 3 sin x minus 4 sin cube x, and from here the formula for sin cube x is equals to 3 sin x minus sin 3x divided by 4. So we can replace here sin cube x with 3 sin x minus 4 into sin 3x. Okay, this can be minus sin 3x upon 4 dx. Now this can be written as 3 by 4 can be taken out, 0 to pi by 2 sin x dx minus 1 by 4 integral 0 to pi by 2 sin 3x dx. Okay. Now we know the integral of sin x, that is minus cos x in between 0 to pi by 2 minus 1 by 4. The integral of sin 3x is minus cos 3x upon 3, and we are also going to put limits here. This can be written as minus can be taken out, and it will give you cos pi by 2 minus cos 0. Minus can be taken common, and 3 also can be taken out, and you are left with cos 3 pi by 2 minus cos 0. Okay. So this will give you cos pi by 2 is 0 and cos 0 is 1. प्लस 1/12 cos 3π/2 को कैलकुलेट करने के लिए आप 3π/2 कैन बी रिटन एज पाई प्लस π/2 and pi plus π/2. This will change your angle into third quadrant where your cosine is positive and cos π/2 is 0. So you can replace cos 3π/2 with 0 minus cos 0 is 1. So this will give you positive 3/4 minus 1/12. And finally you will get this will be 8/12 or we can write it as 2/3. Now your next question is question number 38. Prove that integral 0 to pi/4 2 tan cube x dx is equals to 1 minus log 2. Now to solve this integral, let your I is 0 to pi/4. Integral 0 to pi/4 2 tan cube x dx. Now to integrate this function, we can write our tan cube x as tan x into tan square x dx, and tan square x can in turn written as sec square x minus 1. Okay. Now this will divide your integral into two integrals. Your first one is integral 0 to pi/2 tan x into sec square x into dx, and other one is 2 times 0 to this is pi/4 0 to pi/4 tan x dx. Okay. Now for this question you can make a substitution. Put tan x is equals to t. So sec square x into dx can be written as dt, and we are also going to change our limits. So when x is equals to 0, your t is tan 0, that is 0, and when x is equals to pi/4, your t is tan pi/4, that is 1. So your integrand will become, limits will become 0 to 1. Integrand is t, and sec square x dx can be written as dt minus 2 times integral of tan x is log sec x. Okay, we are going to put our limits here. Now integral of 2t is t square. We are going to put limits here. Minus 2 log of sec pi/4 minus log of sec 0, and here we will get 1 plus square minus 0 plus square. Now sec pi/4 is root 2, so you will get log root 2 minus sec 0 is 1, so we will get log 1, and this will give you 1 minus 2 log root 2, because log 1 is again 0. And here we can rewrite as this 2 raised to power half. Half will come in front of log and this will be cancelled, and we will get our answer, that is 1 minus log. Now your next question is question number 39, that is prove that integral 0 to 1 sin inverse x dx is equals to pi/2 minus 1. Now to solve this integral, let your I is integral 0 to 1 sin inverse of x into dx. Now to integrate this function, we can use by parts. So consider 1 as your second function, sin inverse x as first function and 1 as second function. We can use by parts. First function as it is, integral of second minus integral of derivative of first, integral of second dx, and finally we are going to put our limits. So integral of 1 is x only, so it will give you x into sine inverse x minus derivative of sine inverse x is 1 upon square root 1 minus x square, and integral of x is 1 is x. Okay. Now this will give you x into sine inverse x, and your function is x upon square root 1 minus x square dx. Now to integrate this function, we can use substitution. If we substitute 1 minus x square as t, then minus 2x dx can be replaced by dt. तो माइनस 2 से आप मल्टीप्लाई डिवाइड कर सकते हैं. सो माइनस 2x dx कैन बी रिप्लेस्ड बाय dt. So this will become dt by root t in between 0 to 1. We have not changed our limits. We will substitute back our t into x. So x into sine inverse of x. Now integral of 1 upon root t is t raised to power minus half dt, and that is equals to 2 root t. Okay. So this can be written as 2 into root t between 0 to 1. So 2 will cancel out and we are left with x into sine inverse x plus square root of 1 minus x square between the limits 0 to 1. Now we are going to substitute our limits. So first of all, replace x with 1 and minus. Now finally replace x with 0. So this will give you sine inverse 1 is pi by 2. This will become 0, this will become 0, and this is 1 only. So minus 1. And this is your right hand side. Now your next question is question number 40. Evaluate integral 0 to 1 e raised to power 2 minus 3x dx as a limit of sum. Now, but to find the value of this integral as a limit of sum, we know the formula that integral a to b fx dx can be written as b minus a into limit n tends to infinity 1 upon n into fa plus f of a plus h plus f of a plus 2h plus so on f of a plus n minus 1h, where h is b minus a upon n. This is the formula for the integral as a limit of sum. Now to use this formula, Ri is integral 0 to 1 e raised to power 2 minus 3x dx. So here a is 0, b is 1, and your h is b minus a upon n. So h is 1 by n. So we can write our I as your b minus a is 1, limit n tends to infinity 1 by n into f0 plus f of 0 plus h plus f of 0 plus 2h plus so on f of 0 plus n minus 1h. Okay. Now replace these functions. Limit n tends to infinity 1 upon n f of 0. Your fx is e raised to power 2 minus 3x. Okay. तो f of 0 क्या हो जाएगा? x को आप 0 से रिप्लेस करोगे, you will get e raised to power 2. Now f of h is e raised to power 2 minus 3h. f of 2h is e raised to power 2 minus 3 into 2, that is 6h, plus so on. f of n minus 1h is e raised to power 2 minus 3 into n minus 1h. Okay, this is the function. And now we can take e square common. तो अगर आप e square को common ले लेते हैं, you are left with 1 plus e raised to power minus 3h. This will, you are left with here, you are left with e raised to power minus 6h. That can be written as e raised to power minus 3h whole square. And similarly here, you are left with e raised to power minus 3 into n minus 1h. So you can write minus 3 h raised to power n minus 1 here. And now we know a property that 1 plus x square plus so on x raised to power n minus 1. This can be written as 1 minus x raised to power n upon 1 minus x. So using this formula, we have done this in sequences and series. We can use here, we can write our function this sequence as 1 upon n, and this will become 1 minus e raised to power minus 3h raised to power n upon 1 minus e raised to power minus 3h. Okay. And here we know nh is equals to 1. h is equals to 1 by n. So nh is equals to 1. तो nh को आप रिप्लेस कर सकते हैं 1 से. So you are left with minus 3 upon 1 minus e raised to power minus 3h. Okay. And now 1 minus e raised to power minus 3 is a constant, so that can be taken out. So our I will become e square 1 minus e raised to power minus 3. Limit n tends to infinity, and we are left with 1 by n. न्यूमरेटर में आपका 1 आ जाएगा और डिनोमिनेटर में you are left with this. Now this will become a standard limit. So we know a standard limit, that limit x tends to 0, e raised to power x minus 1 upon x is equals to 1. This is one of the standard limit. तो आप ये बनाने के लिए e raised to power minus 3h है, तो h first of all replace h by 1 by n. So this can be written as minus 3 by n. Okay. और minus 3 by n से अगर आपको इसे minus 3 by n बनाना है, तो as n tends to infinity, minus 3 by n tends to 0, denominator infinite हो जाएगा, तो your minus 3 by n will tends to 0. So we can write here minus 3 by n tends to 0, 1 upon 1 minus e raised to power minus 3 by n upon minus 3 by n. 1 upon n तो ऑलरेडी है, minus 3 से आपने डिवाइड किया है, न्यूमरेटर में -3 से अगर आप मल्टीप्लाई कर देते हैं और -3 से अगर आप डिवाइड कर देते हैं तो इट -3/n कैन बी टेकन इन द डिनोमिनेटर. सो -1/3 आप बाहर ले सकते हैं. Now this will be a standard limit. Limit x tends to 0. 1 minus x e raised to power x upon this is you in fact you have to take minus common. आपको माइनस भी कॉमन लेना पड़ेगा. तो माइनस अगर आप कॉमन ले लेते हैं तो आपके पास क्या आ जाएगा, ये माइनस और कॉमन आ जाएगा तो ये पॉजिटिव हो जाएगा एंड इट विल बिकम लिमिट -3/n tends to 0 1 upon e raised to -3/n -1 upon -3/n. Okay, and this will become 1 here. So your answer is this. Now this can be written as 1 upon e raised to power 3 and finally you will get e raised to power 3 minus 1 upon 3e and this is your final answer. So students, if you like my videos, please subscribe my channel. Have a nice day. Goodbye.